All right, I welcome you back to this class where we are still looking at exponential equation, and this is likely to be the last exercise we are going to do on the exponential equation so that we can move to the next topic, which is going to be law of logarithm. Okay, in this exercise we are given 2 raised to the power 2x plus 1 minus 5 into bracket 2 raised to the power x plus 2 equals to 0. Okay, now just like we have done in the previous exercise, we are going to do the same thing here by breaking down this 2 raised to the power 2x plus 1 here. So this exponent here, we are going to break it down as 2 raised to the power 2x plus 1, giving us 2 raised to the power 2x times 2 raised to the power 1. Okay, so which simply means that we can still write this 2 raised to the power 1 as 2, as in 2 into bracket 2 raised to the power 2x. Okay, and don't forget, from this problem we are given the basic form of this indices to be 2 raised to the power x, which means we are going to write this 2 raised to the power 2x as 2 raised to the power x everything squared. Okay, so we will now replace the whole of this 2 raised to the power 2x plus 1 by 2 into bracket 2x everything squared, so that everything will fall aligned as 2 into bracket 2 raised to the power x everything squared, then minus 5 into bracket 2 raised to the power x, then plus 2 equals to 0. Okay, now we can now see that the exponential equation is now in the basic form of 2 raised to the power x. So here, what we do next is to represent this 2 raised to the power x by a variable. Let's say we represent it by k. So let's k equals to 2 raised to the power x, so that we can have the whole of this exponential equation transforming to quadratic equation. Okay, so I will now replace this 2 raised to the power x by k. Wherever I see 2 raised to the power x now, I will now use k in place of 2 raised to the power x as 2 into brackets k squared minus 5 into brackets k plus 2 equals to 0. Okay, so this simply means we have 2k squared minus 5k plus 2 equals to 0. So we can now see that the exponential equation has now transformed to a quadratic equation, which we are going to use method of factorization to solve. Okay, so how do we solve this by method of factorization is by multiplying the first term here by the last term here, that is 2k squared times plus 2. 2k squared times 2 will give us 2 times 2, 4. 4 times k squared. Okay, now what we do next here is to look for two numbers that when we multiply these two numbers together, they will give us 4k squared. Their product will be 4k squared and their sum will be minus 5k. So the two numbers that will give us 4k squared and minus 5k is minus k minus 4k. Okay, by the time we multiply minus k by minus 4k, minus times minus plus, 1 times 4, 4, then 4k times k squared, that is 4k squared. And when we sum this together, minus k minus 4k will give us minus 5k. So we will now use this minus k minus 4k in place of minus 5k to have 2k squared minus k minus 4k plus 2 is equals to 0. So we now break this as 2k squared minus k, then minus into 4k, then here will be minus 2, okay, equals to 0. Okay, so from here we will now bring out the common factor in 2k squared and minus k, and the common factor here is nothing but k. Why in this case is 2, that is, we factorize 2 here. 2 in 4k will give us 2k. 2 in minus 2 will give us minus 1, excuse me. So I can now have this as k into brackets 2k minus 1, okay, then minus, what is common here is 2 into brackets minus 2 in minus 4k will give us 2k, and minus 2 in in 2 will give us minus 2 in 2 will give us minus 1 equals to 0. Okay, so since what we have here and what we have here is the same, so we can now bring these two together as 2k minus 1, then k minus 2, k minus 2 equals to 0. Okay, now we will now have that either 2k minus 1 equals to 0 or k minus 2 is equals to 0. All right, so from here you can now see that when 2k minus 1 equals to 0, so from here to find our k here, which is the unknown, we can simply say that 2k equals to 1, therefore k is equals to 1 over 2, or 2 raised to the power minus 1, or 2 raised to the power minus 1. All right, then when k minus 2 equals to 0, so we can of course see here that to find our k equals to 2. So we will now recall from this equation 1 where we have let k equals to 2 raised to the power x. So we now recall that k equals to 2 raised to the power x. So we now substitute the value of k equals to 2 raised to the power x here by k equals to 2 raised to the power minus 1. So we now have that when k equals to 2 raised to the power minus 1, and this k is also the same thing as 2 raised to the power x, so we just look for a means to find x. And how do we find x? So when you equate the bases here, so you have that x equals to minus 1. Okay, then we go back to the next one when k equals to 2. So also recall k equals to 2 raised to the power x. So when k equals to 2 here, so when k equals to 2, okay, then 2 raised to our x equals to 2. So when we equate the basis in order to find the value of x here, then our x equals to 1, because this 2 is same thing as we having 2 raised to our 1. So this comes to the end of the exercise. So from here we can see that our value of x is either, therefore s is either equals to plus or minus 1. All right. Of course, we can cross-check what we have done, whether what we have done is right or not, by substituting the value of s equals to plus 1 or minus 1 into the original equation there. So please, you can do that on your own, or if you still need more details on the confirmation on, how to cross-check what we have done, whether we got the answer to be plus or minus 1 as right or wrong. So you can forward the request to me in the comment section, and don't forget to make your own contribution in terms of observation or question for the development of this class. And thanks for watching. Bye.